Route-based VPN. Hello everyone, we have arrived at one of the most exciting parts of this particular setup in our CCSE series, and that is going to be route-based VPNs. Now, what is a route-based VPN? Well, we're going to discuss exactly what it is, how to configure it, and where it is going to be very useful for you in setting up this type of technology. With a route-based VPN, we're going to see that we're going to look at the actual migration from a domain-based VPN that we already talked about to a route-based VPN. Then we will look at the actual dashboard configuration changes that we need to make in order to make this type of technology possible. And then we will look at VTI construction. So what is a VTI? A VTI is a VPN tunnel interface that we're going to be able to set up on each one of our firewalls to set up this point-to-point connection known for a route-based VPN. Then we will look at the actual dynamic routing protocol config that we're going to set up on this type of configuration. We're actually going to inject an OSPF routing protocol into our configuration to get our routes from one firewall to the other firewall. And then we will look at the verification of all this technology in SmartView Tracker. So I do say, take great notes. This is going to be probably one of the most complicated setups that you would do in your studies for the CCSE, as far as taking all the different technologies and putting them together and making this solution work for you so you can understand where this is going to work for you in your own environments out in the real world as well as your CCSE studies. So let's continue on from here and see what's going on with route-based VPNs. So let's set up our route-based VPN now. We're going to make the necessary changes inside of Smart Dashboard and also in the command line of our firewalls in order to get route-based VPN up and running. Now the first thing that we need to do based on the firewall standpoint is we need to jump into the actual command line of your firewalls that are going to participate in this route-based VPN. And in our example, we're going to use Nugget Firewall 1A, Nugget Firewall 1B in our cluster, and our Nugget B firewall. So let's go ahead and load up Nugget Firewall 1A. We're going to log into it. And we need to make sure that we have enabled the dynamic routing protocol or the advanced routing suite on our secure platform firewall. So as we log in, what we have to do in order to get this all running, we issue a pro space enable command. And what this will do is it will turn on the advanced routing suite. And how do you know if it's turned on? You issue a cpconfig command on any checkpoint firewall. And if it's not enabled, you will not see this option right here, because the advanced routing suite, it gives us the option to disable it once it's turned on inside a secure platform. So the point to remember is you need to run a pro space enable on each of those firewalls, reboot them, and then once you get them rebooted, you've pretty much qualified the command line information that we need for now. Now we're going to return to the command line to build some VTIs and to configure our OSPF configuration as part of this nugget, but that's the first step for now. So let's go ahead and issue option number 10. We'll exit to get out of the firewall, and let's go back to our smart dashboard and see what changes we need to make here. So we have quite a few changes that we need to make here as well. If we open up our Nugget cluster and we go to topology, we see the option where we have our actual VPN domain defined right here. Now we're not going to be using an actual VPN domain in this type of setup because it's completely route based. So the first thing that we need to do is go under policy, global properties, and under VPN. We need to select advanced, and we need to turn on this option right here to enable VPN directional match in the VPN column field. So once we have that in place, we're in good shape. We hit OK there, save that, and then we need to go in and set up some encryption domain changes on each one of our firewalls. So as we can see, we currently have this firewall VPN built between Nugget Cluster and our Nugget Firewall B. And it's using our AES 256 with MD5 on the integrity side. So let's go back and make the changes that we need. So let's open up Nugget Cluster, and then we'll select topology. Now right here, we notice that we have this network defined. Now with a route-based VPN, you need to set up a completely blank encryption domain. So there's not going to be any networks defined on this particular object that's placed in the topology table here. So what we're going to do is we're going to call this one blank -enc -cluster. Okay. So with that, we have that in place on our cluster. That looks great. So we'll go ahead and hit OK here. And we're going to do the same thing for our Nugget Firewall B. So go to topology. We see this network. We need to define a group, new simple group, and this is going to be blank dash enc dash b for Nugget Firewall B. So we have that in place. So we hit OK there. Now we save that. Now the next thing that we need to do is, under our actual stealth rule here, we currently have this site-to-site VPN that allows communication between our Nugget cluster and Nugget Firewall B security rule right here on our Nugget mesh, and this is the community that they participate in. Now we're going to use the same community. We're just going to make some changes to the security rule setup. So we're actually, at this point, what we're going to do is we're going to go ahead and take this one out for now, and we're going to build a new security rule. So right below our stealth rule here, we're going to say add rule below, and what we're going to set up here, this is going to be a edit cell, and when this looks a little different than what we have seen previously when setting up a domain-based VPN. So what we're going to have to set up here are these VPN communities. So we'll say add Nugget Mesh is going to participate in this community for the match conditions, and now we need to set up some directional match conditions for the traffic. So we select this, we're going to do add, and we're going to see it's going to be Nugget Mesh to Nugget Mesh. Go ahead and include that one, hit OK there, and that should take care of that for now. Now we need to add the other two options, and that's going to be for the internal clear to the other option that we're going to see under the add parameter right here. Let's add those other two options in that we need for our directional match information. So we're going to do add, and we're going to select internal clear to our Nugget Mesh, hit OK there, and now we need to do the reverse of that type of traffic as well. So we'll do add, and it's going to be Nugget Mesh to internal clear, and that should take care of that parameter for us. Alright, so we hit OK here, and that pretty much takes care of all of the options for this particular security rule that we need to change up for the route-based VPN. So we'll set this to accept. We're definitely going to log this type of traffic, and the push is going to be to our policy targets that's tied under our policy installation target information right here. So that looks good. We have that part of the parameter satisfied. So let's go ahead and save that, and now we need to do the same type of setup on the actual security policy for our Nugget Firewall B. So before we jump over there, we need to make one more change here in order to get this type of information up and running between our Nugget firewalls. Now, I want to show you something that runs between the actual cluster members in a dynamic routing type scenario. So if we go to Window, we're going to go into Smart View Tracker here, and what we're going to see is we're going to see some protocols known as Fib Manager. Now this Fib Manager protocol tends to jump around quite a bit whenever you were talking about setting up a dynamic routing protocol on the actual firewalls. So we can see right here, we see a ton of drops right here for Fib Manager. So what is that? That's the actual protocol that must be allowed between your cluster members when it's running a dynamic routing protocol such as the Secure Platform Pro, like we just turned on. As soon as you turn on Secure Platform Pro, you may start seeing these drops inside of Smart View Tracker, and it's perfectly normal to see this, so you need to put a security rule in to allow your cluster members to speak over this protocol, the TCP Fib Manager 2010. So let's go ahead and do that now. So we'll select this, and where we're going to put this is we can actually drop this in with the internal to internet rule here. So what we're going to see is, what I'll typically do is drop this right above my internal network rule in order to get our traffic flowing between our cluster members. And actually, you know what, we can actually put it up here. Above our stealth rule is probably the best place for us to put it in our firewall management scenario. So what we're going to see here is I'll typically drop this like right below this rule right here, which we have cluster to cluster traffic for CCP, the cluster control protocol, for our sync processes, and I'm allowing ping between our two firewalls so we can ping back and forth between them. But we can actually just go ahead and drop in the Fib Manager protocol to this same rule, and that'll really take care of it. So let's go ahead and name this one cluster dash 2 dash cluster traffic. Alright, and let's go ahead and add that fib manager rule in as well. Okay, so fib manager, we have it in there. That looks good. So we have that part of the configuration change made, and now we need to add one more change to our scenario here, and that's going to allow a protocol for OSPF to be injected across this site-to-site VPN that we're going to be configuring. So we're going to drop that actual OSPF rule right below this current rule that we put in for the VPN traffic. So let's just throw a tag on this of VPN traffic. Alright, looks good. So we'll do rule, add rule below, and it's going to be on edit cell, and tell it that basically on these VPN communities, let's add nugget mesh, put that in, hit OK, and now the actual protocol that we're going to be dealing with is OSPF. So we'll do OSPF is in there, put that in, we're going to accept that, definitely going to log it, and we'll just say routing OSPF. Looks good? Okay. So let's go ahead and save that for now. And now we need to go ahead and make the same type of changes, at least for these two, on top of our Nugget Firewall B in order to get everything working correctly. Now keep in mind, Nugget Firewall B is just a single firewall. It's not a cluster, and it's going to be managed by our Nugget management server. So let's go ahead and save this policy, and we're going to open up our Nugget Firewall B policy like this, and then we're going to make our changes here. So we have some things in place already for our SSL and our remote VPN, that type of information. Now that type of information can stay because we're still going to terminate our remote VPN connections on this particular firewall, but we're going to set up our information like right here where we have our site-to-site VPN. We're going to go ahead and take that particular rule and modify it just slightly. So what we're going to do is go ahead and edit this particular cell. We see Nugget Mesh is going to be part of the cell, but we're going to need to add those directional match conditions. So let's select that. We're going to say add, and it's going to be Nugget Mesh to Nugget Mesh. Good. Then we'll add internal clear to Nugget Mesh. Good. And then we're going to add Nugget Mesh to internal clear. Alright, that looks good. That should satisfy all of our bidirectional traffic that we need. And that looks perfectly fine. So we'll hit OK here. Definitely going to still accept it, and we'll just use the site-to-site tag. It'll be fine. Let's go ahead and open up that other additional rule for our OSPF traffic. So let's do rule, add rule below, and we're going to say for this particular cell, let's add in the Nugget Mesh. Hit OK here. Service, again, is going to be OSPF. So let's put that in place. We're going to accept that, log it, looks good, and we'll just call this one, again, just routing OSPF. Alright, looks great, so let's go ahead and save that for now. So, let me think about this, and I think we pretty much have all of our requirements satisfied here. We should have our encryption domain set to a blank group on each one of the firewalls, which we do. So, blank for encryption B. We should have our directional match information set up. We should be allowing OSPF to be routed between each one of our firewalls and our policies. And we should be able to go ahead and push this out now to each one of our firewalls and get the policy loaded on them. And then we'll continue on with building the actual VTI interfaces that we need on the command line to satisfy the point-to-point links between these two firewalls. So we'll do policy, install. Let's push that out to Nugget Firewall B. We'll go ahead and push this out to the Nugget cluster as well. And then we'll come back and jump on the command line of each firewall and configure those VTI interfaces. So we got our policy installed on the Nugget cluster now. Now we need to make a few more adjustments before we get into our actual VTI configuration. So we'll hit OK here for now. Let's close up our policy on our Nugget cluster. and I want to discuss one thing about our actual topology here. Now we can see whenever we build a cluster interface as part of our regular cluster config, like we saw in this particular series, we had to have an individual IP on each one of the firewalls, and then an actual virtual IP, or the VIP, for the communication between the cluster members. Now we're going to do the same type of setup on our VTI configuration. So we need to set up actual topology information for Nugget Firewall 1A as well as Nugget Firewall 1B, and then we're going to do an actual VIP. And this routing scenario we're going to use here is we're going to use the network 10.20.50 for this side of our VTI, as well as the other side will be 10.20.60, which will be placed on Nugget Firewall B. So what we're going to do is we're actually going to set up 10.20.50.2 to be this particular firewall, .3 will be this firewall, and then .1 will be the actual VIP or virtual IP that will ride between the active cluster member on the actual topology on Nugget cluster. So same type of setup. Whenever we're setting up any kind of interface to be clustered, we got to have two physical IPs as well as the virtual IP defined inside the topology for a cluster. So that technology doesn't change a lot. I just want you to make you aware of that before we dive into the command line and start setting up this information. So let's go ahead and hit OK here for now. Save our current policy, and we're going to jump over to the command line and connect to each one of our firewalls. So now we're going to jump into the command line finally and configure everything on our command line structure for our VTI interfaces. So we're going to start with our Nugget Firewall 1A, and what we have to do to set up our VTI interface, we're going to introduce you to something known as the VPN shell. So what we're going to do is type in VPN shell, and that's going to bring us into this option right here. Now what do we see here? We see quit, we see the interface command, we see a show command to show internal data on our actual VTIs, and we see some tunnel commands where we can look at our actual IPsec and IKE security association information. So to set this up, what we need to do is we need to set up a numbered interface. Now, what you're going to see with VTIs, there's going to be numbered and there's going to be unnumbered. Unnumbered is typically what you're going to see on an IPSO platform, and we're not going to cover that extensively in this particular setup, but what we're going to set up is a numbered interface. That's what you're typically going to run into in any type of checkpoint shop these days, or most people are going to be running secure platform, and if they're doing VTIs, they're going to be doing it in this manner that I'm about to demonstrate for you. So the first thing that we need to do is go ahead and set up our interface VTI for this firewall. We'll do it on the Nugget Firewall 1B or A2 for our secondary firewall in our cluster, as well as Nugget Firewall B. So what we need to do is go ahead and put the actual syntax to work for us. So the first thing we want to do is interface. Now under interface we see some additional options pop up. We have add, we have modify, we have delete, we have show, all those are available. So as we can see, we have a slash interface. Now if we do add, now what do we have? We go up, we have another option right here. The next thing is numbered. So we do NUMBERED, numbered. We hit enter. Now it gives us the option. Now what do we want to add? And it tells us that the syntax that we have to use is the local IP followed by the remote IP, the actual peer name, followed by the interface name. Now the point that you have to remember right here is the peer name. This peer name has to match what you have defined in your smart dashboard application for the firewall that you want to talk to. So in this example, we're going to be setting up our VTI to Nugget Firewall B, so we need to have the exact syntax the same as we have defined right here. Otherwise it will not work and it will not form the VTI for us. So we have the actual syntax defined. So what we're going to do now, we have interface add. So now we're going to issue numbered, and then we're going to actually issue the local IP like it says, and on this side it's going to be 10.20.50.2 on this firewall A1. So it's 10.20.50.2, And then we need to issue our remote IP, where we're going to be talking to 10.20.60.1, which is going to be applied to our firewall on the other side. And then we need to issue the actual peer name. So we hit space, and it's going to be nugget-firewall-b, as it's defined in the dashboard, and it advises us we can give it an interface name. So I'm just going to call this one VT 2B. So we have a virtual tunnel interface to firewall B. Now if we hit enter right here, this is what we should see. We can see interface VTB was added successfully to the system. So that looks good there. So we have the syntax again is local IP, remote IP, the peer name as defined in Smart Dashboard, and then what do you want to call this actual interface name. So now that we have this done on Nugget Firewall A1, it's a good idea to go ahead and just copy this syntax right here, and you can just highlight that in putty in order to get that in place for us. And then we're going to do the same thing on the Nugget Firewall 1B here, or Nugget Firewall A2. So we'll go ahead and get into our VPN shell. Alright, and we're going to do interface. We'll do add, and that'll get us here, and then we're going to do our numbered, and that'll get us to the same place where we were. So we're going to do interface add. We're going to actually just inject that command that we copied over from our previous putty window and change some things up on it, and that'll help us out here and save us some keystrokes. So we'll see. Well, it's being a little difficult. It doesn't want to let us do that. Alright, so it tells us that interface V was added successfully to the system. Well, the thing that we have to understand that we're already have this particular interface defined, but this does get into another point here where you can actually modify the changes as well. So let's do this. What you have to do at this point is we'll do a actual ... and that should take us up. ... takes us up. So if you want to change the directories, just like on any other Unix platform, if you want to go up one level, we can use the ... command. So what we're going to do now is we're going to take that one out that showed up there. So we're going to do interface, or actually we'll do show, just so you can see the syntax. And it's a good time to cover this as well. So we'll do show, and we'll do interface, and we'll tell it to give us a summary or detailed information about the VTIs that are configured on this firewall. So let's do summary, all, and what do we have right here? We have V as defined a Nugget Firewall B to this particular actual IP address, which is on the outside of Nugget Firewall B, and we can see that that actual VTI went ahead and went into an attached status. So it thinks it's going to work perfectly fine, but we haven't pushed policy or anything. So what we want to do at this point is we're going to do an actual ... Let's back up. ... Back up again. ... Back up one more time. So we're at our actual interface parameters. So we'll do interface, and we're going to actually, what we're going to do is actually delete this interface at this point. So we'll do interface, and then we'll do delete, and then we have the option here for peer or interface name. So we're going to do let's do peer V. It says failed to find peer. So let's do interface name V. Failed to delete V. So what we have to do is look at our actual syntax here. On, if we scroll up here, we can see the interface is defined as V, and the peer name is defined as Nugget Firewall B. So let's see if it allows us to take out the Nugget Firewall B option here. So interface delete, and we're going to do peer Nugget -firewall -B. There we go. Successfully remove the interface V from the config. So it's a good time to see that. As I stated, It didn't like our whole putty standpoint there, and that's perfectly fine. It can do that, and that'll work. So what we're going to do is actually put our information in now. So we'll do interface, and we'll do add. We'll do numbered. Okay. And then we need to use the same type of syntax right here, where we're going to do our local IP, which is 10.20.50.3 on this particular interface. We're going to talk to 10.20.60.1, which is going to be on Nugget Firewall B. We need to give it the actual peer name, which is going to be Nugget-Firewall-B as defined in our smart dashboard. And we're also going to call this one VT2B. Now that looks good at that point, and let's see what happens here. Alright, so what do we miss there? What we see here is we missed our numbered command. So let's do add, and then we'll do numbered to 10.20.50.3 to 10.20.60.1. Put our peer name in. Give it an actual interface name, VT2B, and it took it. So we'll go ahead and do ... and ... and we'll issue a quit command to get off on this particular firewall. And let's jump to Nugget Firewall C or B. At this point, we're going to set up that actual communication. So what we see here is we have Nugget Firewall A1 and Nugget Firewall A2. So let's go ahead and jump to our dashboard here, or our desktop. Let's open up our putty application, load up Nugget Firewall B, which is on the outside, was our .30. Let's open this up, and we'll go ahead and log into it. Okay, so we're already in expert mode. So let's do an actual VPN shell, and we need to add the same type of setup. So we'll do interface, add, numbered, and we need to do the reverse of that process. So the local IP in this case is the 10.20.60.1. Now what are we going to be talking to? We're going to be talking to that virtual IP where we set up the 50.2 and the 50.3 on the cluster members. All those are going to talk to the virtual IP of 50.1. So it's going to be 10.20.50.1. And again, now we need to put our actual peer name in, and it has to match exactly what's in Smart Dashboard. So this is Nugget-Cluster, and this is going to be VT2 cluster. And there we go. It was successfully added to the system. So we should be in good shape here. Let's do a ... again. And we'll issue a quit command. Or actually, let's do something. Before we do that, let's do a run through our actual verification. So we'll do show, and we'll do interface, detailed, all, detailed, all. There we go. So what do we have here? We see our actual interface VT to cluster. We see the internet IP address on our side is 10.20.60.1. The point-to-point to the peers of 50.1. We can see that this is a 32-bit subnet mask, so that's a point-to-point connection, and our current status is attached. So we have our complete VTI interface between Nugget Firewall B and the Nugget cluster established. Let's do the same type of verification over on this guy. So we'll do ... and ... and let's do actual show, interface, detailed, all, and we see our current status is attached. So we're in great shape there. So that satisfies the actual VTI information, and it's completely attached between our Nugget Firewall cluster and our Nugget Firewall B, and we could do the same type of verification just to make sure everything is working as expected on Nugget Firewall 1B. So let's do that. Or A2. The secondary firewall in our cluster is the point. Okay, so let's go ahead and do VPN shell. And let's get into that syntax. Alright, great. So then we'll do show interface detailed all, and we're attached here as well. So we see that we have all that in place, so we're in good shape. So let's do a ... Let's quit from here. And we can actually exit out of our command line on each one of these. So we want to make sure we get all the way back, and we'll issue our quit commands. And we'll do our exit commands to actually get out of the command line. And we're going to do this on all three of these shells that we have in place. Okay. Quit. Exit. Alright, so all of our shells are taken care of. Now we need to jump back to our dashboard, and we need to go in and fetch our topology. So let's start with our Nugget cluster here. And if we go under our topology, we see this. If we go to edit topology and we tell it to get all members topology, look what it did. It actually pulled our virtual tunnel interface, our VTI point-to-point connection. So now we need to set up our actual cluster information. So we'll do VTP or VT2B, and the actual VIP or virtual IP we've been talking about is the 10.20.50.1, and it's going to say it may change up our topology, and that's okay. So we'll hit OK for now. So there we have it. We have our VT2B for our virtual tunnel interface. We have our 1020.50.1 to 1020.50.2 and 1020.50.3 as it's set up on our cluster. We'll hit OK here for now, and we should be in great shape. So we'll go ahead and save this policy. We'll jump over to our Nugget Firewall B, open this up, go to topology, tell it to get interfaces, and it says the fetch query failed for us. And the reason why this is because we're not directly behind this type of setup at this point. So it's saying VTP to cluster 1020.60.1, but actually it ended up doing it for us because we are managing Nugget Firewall B with our Nugget management server. So we'll accept that. So I don't know exactly why it did that earlier. Let's try it again. Okay, it must have just freaked out for a second there. So it is working. We see our 1020.60.1, which is the VTI on Nugget Firewall B. The 30.2 is our internal interface. The .30 on the 172 is our external. So we will accept that. We hit OK. We'll say yes to that. Now it actually prompted us about our actual anti-spoofing information. So let's go ahead and take a look at that as well. And we'll tell it to perform anti-spoofing based on the interface topology. We'll hit OK there. Click OK on that. Open up Nugget Cluster. Go to Topology. Edit Topology. And let's do the same thing on our VT interface. So we have this here. Let's edit our interface. Topology. Perform anti-spoofing is already on this particular one. So we'll hit OK there. OK here. OK here. And now we should be able to actually do a policy install. And we're going to push this policy out to our Nugget cluster. And we're going to push it out to our Nugget Firewall B. And that's going to be step 2 in our scenario. Now the last thing we're going to have to configure is our actual dynamic routing protocol using OSPF. And we'll configure that via the command line again of each one of our firewalls. So let's get our policy pushed out. And then we'll return, jump on the command line, and get everything configured properly. So now we're going to go ahead and set up our VTI routing using OSPF on the command line to get our routing between our Nugget cluster and our Nugget Firewall B working using OSPF across that VTI interface that we defined. So the first thing that we want to do is go ahead and get on the command line. We're going to jump into Nugget Firewall A1, and from your expert mode prompt you need to issue a CLI gate D command, and that'll actually give you command line access to the routing daemon that's built into Secure Platform. So we'll issue an enable command just like a Cisco router, just to enable the prompt to get us into the privilege mode. We'll issue a config T command to get into configuration mode, and now we need to issue a router OSPF process ID number. So we're going to do router OSPF 1. Alright, so that brings us into that process, and we're going to issue a router ID. And on this particular firewall, that router ID is going to be 192.168.2.10. Okay, and now we're going to issue a network statement to get our network advertised for what we want to talk to on the other side of the OSPF cloud. In this case, it's going to be network. It's going to be 192, or actually, it's going to be 10.20.60.1 space and then 0.0.0.0, and we're going to be using area 0 in this case. So area 0.0.0.0, and that should be a good statement. And now we need to issue some redistribute commands. So we're going to do a redistribute of our directly connected routes. So let's do that. And we're also going to do a redistribution of our kernel routes. So let's do that as well. So that should be good there. Let's exit out of here. Do a write mem to save our config. And then we'll do a show run. And this is our current running configuration. And this is what we want to drop essentially on our other router. So let's go ahead and copy this, or our other firewall, which is going to run our routing process on the Nugget Firewall A2, which is our secondary firewall in our cluster. So we have that copied. Let's go ahead and jump over to that particular firewall at this point. And this is where we're at now, where we can issue our CLI gate D command. And then we can enable, and then we can go into config T. And we're going to issue our router OSPF command. So essentially we should be able to drop all that in there. So what we're going to see is router OSPF1. We have our router ID, our network statement, our redistribute of our directly connected routes, and our kernel routes. All should be on this particular firewall now. So let's go ahead and exit from here, do a show run. Let's actually do show run. There we go. So we see our actual configured information at this point. So we should be in good shape now. Last thing we need to do is go ahead and jump over to our Nugget Firewall B, and that's going to be right here. And we're going to issue the same type of config, but just in a little bit different statement process to get to the Nugget cluster. So we do CLI gate D. We enable this particular option, and once we're enabled into this privilege mode of this routing process, now we're going to go ahead and issue a config T, and we're going to do router OSPF1, and then we're going to do our actual router ID. In this case, it's going to be 192.168.1.10. So it's going to be a little bit different router ID. And we'll see that as part of our OSPF verification in a few minutes. That way you can see where your routing updates are coming from. In this case, the router ID would be the 1.10 from the B firewall. So we'll hit enter on that. Let's put our network statement in. And that's going to be 192.168.50.1 on the other side of the VTI. And then it's 0.0.0.0. And that's also going to be area 0.0.0. Actually, there's two dots there. So let's do 0.0. Okay, so it took that. So let's do another redistribute of our directly connected routes. And then we're going to do a redistribution of our actual kernel routes. Well, let's try that again. There we go. Alright, so let's exit from here, write mem our config, show run our config, and we have our running config at this point. So now that that's done, we should be in pretty good shape here. Let's go ahead and do a show IP route on this particular machine. So what we see here is we see our kernel routes right here, we see our connected routes, and we see our static route pointing back to our local loopback. What we do not see at this point is our actual OSPF routes, so those haven't formed yet. So what we need to do in order to get those to form properly is go ahead and reinstall our policy. Once we reinstall our policy, it's actually going to go through and form our OSPF adjacency between our Nugget Firewall B and our Nugget cluster across the actual VTI interface. So let's just do a quick verification. Let's see if it formed yet over here. It probably hasn't, but we might need to reinstall policy to get this done. So we can see our adjacency hasn't formed. So what we're going to do at this point is go ahead and jump over to Smart Dashboard, load this up, and get our policy reinstalled on the firewalls. So we'll click out here. Let's go ahead and load up our Smart Dashboard, do a policy install. We'll push this out to our Nugget cluster, and then we'll push our policy out to our Nugget Firewall B, and that should get our OSPF adjacency flowing correctly and form our VTI and our VPN. So I went ahead and pushed policy out to each one of our firewalls again, just to see if we can get our OSPF adjacency to wake up for us. So now that we've done that and the policy has been delivered to our Nugget cluster as well as Nugget Firewall B, let's get on each one of the firewalls and check out our routing configuration. So from our actual gate D configuration, we can do a show IP route command, and what do we see? Great, we're in great shape. We see our actual O here. So this is going to show us that we have our actual OSPF routes being injected into the Nugget Firewall cluster. Firewall for A1 here at this point. Let's look at the same thing on Nugget Firewall B. So we do show IP route. Looks good. So there we go. We're in great shape. So you see the beauty of this, and the point to remember, whenever you need to move a multicast protocol across a typical VPN, that typically is not going to work for you in most situations with a standard IPsec routing protocol, due to the size of some of the routing updates such as OSPF, BGP, EIGRP, or anything that's going to use a multicast type of broadcast to deliver its actual routing information. And that's where we need to establish a route-based VPN using our VTIs in order to get that kind of information to routers behind Nugget Cluster or routers behind Nugget Firewall B. This is going to be very useful. You're also going to find this to be a failover option should you lose a network connection to the outside internet world. Let's say, for example, you have an MPLS circuit from maybe AT&T or XO or one of the major providers, and that primary circuit goes down. If you have a VTI connected on the secondary circuit, maybe on cable or a DSL connection, you can remain working because that type of traffic will fail over, and you'll be able to form the route-based VPN using a VTI and get the traffic for your users between your sites without a problem should you lose your primary MPLS circuit, for example. So, as stated, once we were able to push our policy again, we can see that the actual OSPF routes were injected into each one of the firewalls. So let's do some other verification. We're going to do show IP OSPF route. Let's try that again. Okay, it's not liking that one. So let's do show IP OSPF. There we go. So that's the one we were looking for. And what this is going to do is give us all the information about the actual OSPF process that's running between these firewalls. It's going to tell you the actual area information, the LSA information, the actual autonomous system boundary router information. Now this is more of a scope for a CCNA routing scenario when we get into deep into the routing protocols, but I just wanted you to see these type of information so you can see some basic information here. And let's look at one more. It's going to be show IP OSPF neighbor, and this is going to give you the information about your neighbor address. So what we see right here is that from Nugget Firewall B, our actual neighbor is being advertised on this router ID of 2.10. So that's why we actually put the router ID on our actual OSPF process when we configured it. That way when it actually sends out our routing update for OSPF process 1, what we can see is that it came from 192.168.2.10, which was the Nugget cluster's router ID. And we can see that the interface address was 10.20.50.2, so that's where it came from. As we can see, that's coming from our primary cluster guy. If we remember our topology scenario where 50.2 was on the first firewall and 50.3 was on the secondary firewall, with 50.1 being the actual VIP or virtual IP on that cluster member. So also what we're going to see is that it's in area 0 and it's being delivered over interface VT to cluster. So it's using our VTI interface in order to make this connection possible. And we see our neighbor priority. We see our state changes to full 7 state changes. And it talks about our designated router here and our backup designated router. And our option is, then we see our actual dead timer. How long is the actual route valid for? If we don't see any kind of communication for 39 seconds, we will determine that that route is dead. So now that we have that in place, we should be able to jump over to our actual command line and just ping behind the Nugget Firewall B. So it's going to be 10.20.30.2, and there we go. That is the actual interface that's connected to the inside of Nugget Firewall B. So we're actually coming from our host that's actually behind our Nugget cluster. So if we do a trace route to 10.20.30.2, we can see our first hop here is our 10.21.2, which is our Nugget Firewall A, and then we're going to see that the second hop delivers us to the internal interface of the Nugget Firewall B. So there we go. We have a complete solution that's going to work for us. We have our route-based VPN in place. We have our dynamic routing in place using OSPF, so we are in good shape to have the failover and have the redundancy that we need, and to definitely satisfy the requirements for learning about OSPF and route-based VPNs in general. In this nugget on route-based VPNs, we learned a ton of information. First, we looked at the actual migration of the domain-based VPN to a route-based VPN, where we made the changes inside of the rule base as well as our topology fields, and we took care of all the actual dashboard changes that we needed. And then we looked at our actual VTI construction, where we built our VPN tunnel interfaces via the command line in order to form the connectivity between the Nugget cluster and Nugget Firewall B. Then we looked at the actual dynamic routing protocol config, where we set up OSPF in our environment and got our OSPF adjacency working between both the firewalls. And then we ran through the actual verification of that traffic, making sure that we can reach the other side of the tunnel behind Nugget Firewall B. I hope this has been informative for you, and I'd like to thank you for viewing.